There is a place on Earth so dangerous that engineers could not build there. Not because of wind, not because of water, because standing next to it would kill you. The ruins of Chernobyl's Reactor 4 are still so radioactive that a construction crew simply cannot work above them. And yet, something had to be built over that reactor, or the radiation inside it would eventually escape into open air. So engineers came up with one of the boldest solutions in construction history. If you can't build on the spot, don't. Build the largest movable structure in the world a quarter of a mile away where it's safer. Then push it. Push 36,000 tons of steel across the ground, inch by inch, until it swallows the reactor whole. It sounds insane. They did it. Here's how. Now watch why they had no choice. April 26, 1986. During a safety test gone wrong, reactor number 4 at the Chernobyl nuclear plant in Ukraine explodes. The blast blows the lid off the reactor building and throws burning radioactive material into the open sky. The core catches fire and burns for days, pumping a plume of radiation across huge parts of Europe. It is the worst nuclear accident in human history. And when the fire is finally out, an even bigger problem is left behind. Inside those ruins sits the melted core. Tons of highly radioactive fuel mixed with concrete and sand. Exposed, open to the weather. Every rainstorm risks washing radiation into the ground and the water. So the Soviets do something desperate and heroic. In just a few months, workers throw together a concrete and steel shell over the wreckage. It's called the sarcophagus, literally a tomb. Tens of thousands of people work on it in unbelievable conditions, some of them rushing onto the roof for less than a minute at a time because that was all the radiation exposure a human body could take. And it works.
It was a desperate race against time, built under lethal conditions. But this first tomb was never meant to last.
But everyone knows the truth. The sarcophagus was built in a screaming hurry in a lethal environment. It couldn't be welded properly or sealed properly. It was only ever meant to hold for about 30 years. And here's the ticking clock. By the 2000s, that shelter is old and failing. Rain leaks in, the steel corrodes, the structure sags and cracks. Engineers realize something terrifying. If the aging sarcophagus collapses, it would slam down onto the radioactive ruins beneath it and punch a cloud of radioactive dust straight back up into the air. Chernobyl could contaminate Europe a second time, not from an explosion, but from a roof falling in. Something new has to cover it, and fast. Here's the core engineering problem, and it's brutal. You need to build a gigantic new structure over Reactor 4, but the ground right there is still one of the most radioactive construction sites on the planet. Workers standing on top of that reactor could only work in tiny, rationed doses of time before hitting their lifetime radiation limit. You simply cannot run a normal multi-year construction site there. Cranes, welders, scaffolding, thousands of workers day after day, for years, directly above an exploded reactor? Impossible. Now the numbers of what they built anyway. An arch 257 meters wide, 108 meters tall, taller than the Statue of Liberty, which would fit inside it with room to spare. Long enough to cover the entire ruined reactor building, and it weighs about 36,000 tons. That's roughly 3 times the weight of the Eiffel Tower. Now imagine moving that. On paper, madness. All they had to do was build it. So here's the solution, and it's the whole reason this project is legendary.
The solution was brilliant. Don't build directly over the deadly core. Build it nearby, where workers can actually survive.
Don't build it over the reactor. Build it next to the reactor. Engineers pick a spot a few hundred meters away and clean it up, stripping contaminated soil and laying down fresh material to make a safer work zone. And in that cleaner patch of ground, They assemble the entire colossal arch. Workers can spend real time there. They can weld, lift, and bolt like a normal construction site. The reactor sits nearby, still deadly, but the men are not standing on top of it. And the arch itself is built in a clever way. It goes up in two separate halves. Each half is assembled lying low to the ground first, then jacked upward in stages, with new steel sections added underneath as it rises. So crews are always working near ground level instead of dangling hundreds of feet in the air. Once both halves are complete, they're rolled together and joined into one continuous arch. Steel parts arrive from factories across Europe and get bolted together on site like the world's heaviest kit. And why an arch? Why not a simple box or a warehouse shape? Because an arch is the strongest shape you can use to span a huge distance with nothing supporting the middle. It carries its own weight outward and down into its 2 feet, instead of sagging in the center. That matters enormously here, because you can't put a single column or support anywhere inside. The ground underneath is the destroyed reactor itself. The whole span has to leap clean over the wreckage and touch down only on either side. The arch also has no flat roof for snow to pile on and no big surfaces for wind to grab. Simple shape, perfect job. Then comes the skin. This isn't just a metal roof. It's a 2-layer shell with a gap between the outer and inner walls. And that gap is the secret to making it last a century. The enemy of any steel structure is corrosion. Rust eating it from the inside out. Exactly what destroyed the old sarcophagus.
To stop rust from eating the structure from within, engineers designed a massive, high-tech double-layer shell.
So the space between the layers is filled with conditioned, dried air, keeping moisture off the steel. The arch is designed to stay dry inside its own walls, so it doesn't rot the way its predecessor did. Built to stand for 100 years. But now the real problem. The finished arch is sitting hundreds of meters away from where it needs to be. How do you move the heaviest movable structure ever built, without cranes, without wheels, without breaking it in half? But before anything can move, there's groundwork nobody talks about. You need rails for the arch to travel along, and those rails need massive concrete foundations running all the way to the reactor, right through contaminated ground. So crews have to dig and pour in exactly the kind of soil everyone is trying to avoid. Every scoop of earth is monitored. Workers rotate out on strict time limits. Just building the road for the building to walk on is its own hazardous project. Here's the trick, and it's beautifully simple. Skidding. The arch sits on special rails with pads of Teflon, the same slippery stuff used to keep food from sticking to a frying pan, to cut the friction down. Then, instead of pulling it, they push it. A system of 224 hydraulic jacks grips the structure and shoves it forward about 60 centimeters at a time. Then the jacks reset and grip again. Push, reset, push, reset. Each stroke is barely the length of your arm. In November 2016, the push begins. 36,000 tons of steel start crawling across the ground toward the reactor at a pace slower than a snail. The whole time, sensors track the arch's exact position. If one side moves faster than the other, the structure could twist and jam or damage itself. So it has to advance almost perfectly straight, 60 centimeters per stroke, over a distance of 327 meters.
36,000 tons of super steel, crawling slower than a snail, advancing perfectly straight across the fields.
That's over 3 football fields of travel. In total, about 40 hours of actual pushing, spread across roughly 2 weeks of careful monitored work. And then, at the end of November 2016, it's done. The arch settles over Reactor 4, completely swallowing the old crumbling sarcophagus inside it, like one tomb built around another. The most dangerous ruins on the planet are sealed under the largest movable structure humans have ever made. And here's the part that gets me. Almost nobody ever had to stand on top of that reactor to do it. But sealing it was never the final goal. And this is what most people don't realize. The arch isn't just a lid, it's a workshop. Because eventually, that old sarcophagus and the radioactive wreckage underneath have to be taken apart and dealt with. Otherwise, you're just leaving the problem for your grandchildren. So hanging from the ceiling inside the arch are enormous remote-controlled cranes. Machines that can reach down and dismantle the ruins from above, operated by humans sitting safely elsewhere. The arch buys the time and the shelter to disassemble Chernobyl by robot, piece by piece, without exposing people to the core. And this wasn't one country's project. More than 40 nations put money into a shared fund to pay for it, coordinated through an international bank, with a French construction consortium doing the build. The total bill came to around 2 billion euros. Think about that. Dozens of countries, decades after the disaster, paying together to contain a wound in the middle of Europe. Radiation doesn't respect borders, so neither did the response. But the story didn't end there. In February 2025, a drone struck the arch during the war in Ukraine. It damaged the outer skin and started a fire that took a long time to fully extinguish. But that inner layer, the second shell, held. Monitors reported no release of radiation.
Even after taking an unexpected strike, the inner shield held, keeping the threat completely contained.
The structure designed to survive 100 years of weather ended up taking a hit nobody planned for, and it kept the reactor sealed. Since then, engineers have been assessing the damage, and the site has faced power interruptions from strikes on Ukraine's grid. The arch is holding, but it's a reminder that this thing needs constant care and constant electricity for generations. Here's the bottom line. Chernobyl created a problem with no good answer. You can't leave an exploded reactor open to the sky, but you also can't send people to build on top of it. So engineers found the third option. They built the shelter somewhere safer, made it the largest movable thing on Earth, and then slid it over the wound 60 centimeters at a time. They didn't beat the radiation. Nobody can. They outthought it by moving the building instead of moving the people. And now, a 100-year clock is ticking inside that arch, while robots slowly take apart the worst accident in nuclear history.
But sealing a disaster is one thing. What about building where nature itself fights back? Half a kilometer into the sky, where the wind alone can tear a tower apart. Or out into the open sea, on ground that doesn't even exist yet. That's next time. If you love watching humans take on the impossible and win, subscribe. This is the kind of story we break down here. See you at the next impossible structure.